Now this problem is related to calculating pH of a buffer solution. There are two kinds of buffer. We can have a acidic buffer, we can have a basic buffer. This problem is related to acidic buffer. Question says, what is the pH of a buffer that is 0.12 m in lactic acid and 0.1 m in sodium lactate? So this means we have to calculate pH of a buffer, and we have been given concentration of lactic acid, that is concentration of acid. So when we have a buffer, we will have a acid, that is weak acid. So what is buffer? Buffer is a weak acid plus salt of the same weak acid, salt of weak acid. So in this problem, lactic acid is a weak acid and sodium lactate, that is corresponding salt. Lactic acid concentration is given, that is 0.12 m, and sodium lactate concentration is also given, that is 0.10 m. Now for acidic buffer, we will use the formula, that is Henderson-Hasselbalch equation, that is pH is equals to pKa plus log concentration of salt divided by concentration of acid. Now this is an easy problem. K is given, K is 1.4 into 10 to the power minus 4. So we can calculate pKa, that is minus log of Ka. So this is minus log of 1.4 into 10 to the power minus 4. So let us use calculator. Log of 1.4 10 raised to the power minus 4. So this is 3.85. So this value is 3.85. Now we can calculate pH. We know pKa, that is 3.85 plus log concentration of salt. Salt is 0.01 m, that is sodium lactate, divided by concentration of acid, that is 0.12 m. So we can calculate this value, that is we have 3.85 plus log of 1.1 divided by 0.12. So this is 3.77. So pH for this acid is, pH for given buffer, that is acidic buffer, that is 3.77. And this is obvious because pH is coming, that is less than 7. So corresponding buffer is a acidic buffer. So whenever we have a buffer solution, we'll use this formula to calculate pH, that is Henderson-Hasselbalch equation. pH is equals to pKa plus log salt by acid.